Once again, welcome to the new session of engineering graphics, that is the development of solids. Actually, the development of solids is the engineering applications of principles of projections of solids. Sectioning a solid. An object is cut by some imaginary cutting plane to understand the internal details of that object. The action of cutting is called sectioning, and the plane of cutting is called section plane. Generally, there are two types of cutting planes. Type A plane, see in this figure, type A plane, this is the cutting plane. It is perpendicular to VP and inclined at an angle with HP. So it is an auxiliary inclined plane. Type B is a section plane which is inclined to VP and perpendicular to HP. So it is an auxiliary vertical plane. There are two types of, generally there are these two types of cutting planes are used. After launching a section plane, either in front view or top view, the part towards the observer is assumed to be removed. That is the rule. And second rule is that as far as possible, the smaller part is assumed to be removed. Here in this figure, this portion is removed, the top portion is removed. In this figure, in type B, this smallest portion is removed, and we draw the sectional views. This illustration gives an idea about a section of a pyramid, square pyramid. This is a section plane, and this is the true shape of this sectioned portion. This is the top view of the sectioned portion. This line is called hatching line, or hatching lines are drawn 45-degree inclined to the axis. So these two are named as hatching line. Usually thin lines are drawn for hatching. Typical section planes and typical shapes of sections. A cone is cut by a section plane which is passing through the apex. Then we get a triangle. Another section plane passing through this direction, we get the shape of an ellipse. In this section plane, we get a parabola. This is the section plane. If it is cut through this direction, we get a hyperbola. When a cylinder is cut in this direction passing through all generators, we get the shape of an ellipse. When a square pyramid is cut through the slanted slide, we get the shape of a trapezium. Development of surfaces of solids. Assume that the object is hollow and made up of thin sheet. Cut, open it from one side and unfold the sheet completely. Then the shape of that unfolded sheet is called development of the lateral surfaces of that object or solid. Lateral surface means that is the surface excluding the top and base of solid. There are so many products or objects which are difficult to manufacture by conventional manufacturing processes because of their shapes and sizes. Those are fabricated in sheet metal industry by using development techniques. There is a vast range of such objects. For example, boiler shells, chimneys, pressure vessels, shovels, trays, boxes and curtains, feeding hoppers, large pipe sections, body and parts of automobiles, ships, aeroplanes, and many, many more. So before going ahead, understand these points. Development is different drawing from projections. We have studied the projection of points, lines, etc. And this topic is entirely different from those projections. It is a shape drawing, or it is a drawing showing the area, means it is a 2D plane drawing. Hence, all dimensions of it must be true dimensions. Usually, dashed lines are not used since there will not be any hidden portions in it, and actual dimensions are used to draw the development. Some examples are given here. A cylinder, its development is a rectangle, excluding its top and base. This portion is the development. So pi d is the development of the lateral surfaces of the cylinder. And of course, it contains a top, a circle here, and bottom also there will be a circle that gives the full development of the cylinder. But the lateral surfaces means the surface of the revolved portion. It is a hexagonal prism. So its development gives 6 times the side. Its side is S. So this is 6S. And this is the height of the prism. A cone. This is the slanted length L, and it is drawn like this. R is the radius of the base circle. So theta can be calculated using the equation R by L into 360, where R is the base circle radius, S is the slant height. Theta can be calculated. And this shows the development of the cone. Pyramid. It consists of 4 triangles and a rectangle and a square. A square pyramid. Its development is similar to the development of cone, but the difference is that its base are marked as straight lines with 4 sides. Its side is S, so here it is 4 S are marked here. That is the development of a square pyramid. Tetrahedron consists of 4 equilateral triangles, one at the base and 3 on either sides. The base and at the 3 sides. We know a cube consists of 6 squares. This is the development of the lateral surfaces of a cube, but including top and base, this gives the development of a cube. Frustums, development of frustum of a cone. So this is a slanted height, slanted length L, and the cut portion is length L1. We can draw the development. Where R is the radius of the base circle, L is the slanted length. So theta can be calculated using R by L into 360 degree. Mark theta here, and this is the length of the slanted length, and this is the smaller length L1. It is completed. So this is the development of the frustum of a cone. Development of frustum of square pyramid. This is base side. It consists of 4 sides and 4 triangles. This side is here, top side. All are straight lines. So this gives the development of the frustum of square pyramid. And problems are included here. A pentagonal prism, 30 millimeter base side, 50 millimeter axis is standing on HP on its base, whose one side is perpendicular to VP. It is cut by a section plane 45 degree inclined to HP through midpoint of axis. Draw the front view, sectional top view, sectional side view. Also draw the shape of section and development of surface of remaining solid. So here it is given that one of its base side is perpendicular to VP. So draw the top view first in such a way that one of its base side is perpendicular to VP. This side is perpendicular to VP. Draw the regular pentagon. Name it. Also draw its front view. It is cut by a plane 45 degree inclined to HP, section plane, and passing through the midpoint of axis. This is the axis. It is passing through the midpoint of this axis. Name those points, and we can see the shape of the cut portion in the left side view only. So for drawing the left side view, this is projected to right like this, and it is projected upwards, and these points are projected to right side, and name the points. Complete it using straight lines. The bottom portion is drawn like this. This portion is hatched. Similarly, the top portion is also hatched. If you want to get the true shape of the section plane, draw a line or another axis x1, y1 parallel to the cutting plane. So x1, y1 is parallel to this cutting plane. Now project these points towards this. Now mark the distance of A1 from x1, xy to A. This is A. Similarly, from xy to E, we can mark E here. From xy to B, we can mark B here. This is E, this is B, and this is D. This point is E. These are drawn using thick lines. That portion also is hatched. This is the true shape of the sectioned portion. Now draw the development. Pentagon, being a pentagon, here it consists of 5 rectangles, pentagonal pyramid. And these cut portions are projected to these lines, and that points are marked. They are connected using straight lines. This is the development of the truncated portion, means bottom portion. Another problem, a cone 50 mm base diameter and 30 mm axis is standing on its base on HP. It is cut by a section plane 45° inclined to HP through base and generator. Draw projections, sectional views, true shape of section and development of surfaces of the remaining solid. So first of all, draw the top view, divide it into 8 equal divisions. If you divide it into 12 equal divisions, we get more points for plotting. It is better to divide it into 12 divisions and draw. Here it is divided into 8 equal divisions. It is projected upwards and these generators are drawn. Now its side view is drawn here. So this end, that is point A, comes front because it is cut by a section plane passing through the base end generator, passing through the base end generator section plane. To get it in the top view, project these points downwards. To project a point from the center line, it should be projected first towards the generator, outer generator or side O dash A dash. Then it is projected downwards to OA. From there it is drawn to arcs to either side to C and G direction. And mark those points. Similarly, it is projected towards right as well, and those points are joined using a smooth curve. This portion is hatched. This portion also is to be hatched. To get the true shape, as in previous case, draw a line x1, y1 parallel to the cutting plane. These points are projected towards that, and the distance from A to here and H to H, etc. are marked. And we know when it is cut by an inclined plane, we get the shape of an ellipse. So an ellipse is drawn here. This is the true shape. To draw the development, mark theta and draw the development. Draw all the generators, 8 generators are drawn here, and these points are marked taking the true length from the side. Those points are connected using a smooth curve. This gives the development of the remaining portion of the cone. Third problem, a cone 40 millimeter diameter and 50 millimeter axis is resting on one generator on HP, that is lying on HP, which is parallel to VP. That generator is parallel to VP. Draw its projections. It is cut by a horizontal section plane through its base center. Draw sectional top view, development of the surface of a remaining part of cone. So first of all, draw the top view of the cone, then draw the front view, then draw or reproduce this in such a way that the O dash comes here and E dash comes here. This point is O dash, this is E dash. So it is lying on HP. This gives its top view. Now it is cut by a section plane which is passing through the center through its base center. A plane through its base center. So this is the cutting plane. The top portion is removed. You have to draw its top view. So those points are projected downwards and they are connected using smooth curve and it is hatched. Draw the development. These points are marked here. This portion is removed. Portion containing A, B, H, etc. are removed. So this is removed. And this portion is also removed. Top portion. Fourth problem, a hexagonal prism 30 millimeter base side and 55 millimeter axis is lying on HP on its rectangular face with axis parallel to VP. It is cut by a section plane normal to HP and 30-degree inclined to VP bisecting axis. Draw sectional views, true shape and development. Hexagonal prism of 30 millimeter base side and 50 millimeter axis is lying on HP. So draw the top view first, then its front view, and reproduce it in such a way that it is lying on HP. It is cut by a section plane normal to HP and 30-degree inclined to VP bisecting the axis. So the cutting plane should pass through the center of this axis and inclined at an angle 30 degree to VP, and it is normal to HP as well. So AVP 30 degree inclined to VP through midpoint of axis. Name those points as 1, 2, 3, 4, 5, 6, 7, 8. Project those points to top and left side. The cut portion. This portion is removed. The remaining portion is shown here. To get the true shape, draw a line parallel to the cutting plane and project these points towards that line. These distances are marked. This is 0.8, 0.1 to 0.7, 0.6, etc. So this gives the true shape of the cut section. This is the front view of cut section. It is a development having 6 rectangles. A solid composed of a half cone and half hexagonal pyramid is shown in figure. So this is half cone and half hexagonal pyramid, its front view, its top view. It is cut by a section plane 45 degree inclined to HP and passing through the midpoint of axis. So this is the cutting plane passing through the midpoint and inclined at an angle 45 degree to HP. Draw front view, sectional top view. We have drawn the front view here. To draw the top view, these points should be projected downwards. To project the points 2 and 6, it is brought to left side or right side. It is brought to right, then projected to line OA. From there, an arc is drawn with the center O and radius equal to this distance. So we get 2 and 6 here. Join all these points and hatch it. To draw the true shape, as in previous cases, draw the true shape of the cut section. Its true length are marked, and this gives the development of the bottom portion. Another problem, draw a semicircle of 100 millimeter diameter and inscribe a largest circle in it. If the semicircle is development of a cone and inscribed circle is a curve on it, then draw the projections of cone showing that curve. This is a reverse method. So first of all, we are drawing the development. Drawn a semicircle of 100 millimeter diameter and a largest circle is inscribed in it. Now divide the semicircle into 8 equal parts, which gives the development of a cone. This is the slanted length L, and theta is 180 degree here. Being a semicircle, this is 180 degree. So from that we can calculate R, that is the radius of base circle. Theta is 180 degree. From that R can be calculated and draw the top view of the cone. Draw its front view also. This is the slanted height L. L is here. It is marked from here to the center line. Now these points are plotted in the front view and top view as well. And draw a smooth curve using all these points. Similarly, draw the points in the top view as well. Draw a smooth curve passing through these points. We get the true shape. Draw a semicircle of 100 millimeter diameter and inscribe in it a largest rhombus. If the semicircle is development of a cone and rhombus is some curve on it, then draw the projections of cone showing that curve. So first of all, draw a semicircle of 100 millimeter diameter and inscribe in it a largest rhombus. The largest rhombus is inscribed in it. Divide it into 8 equal parts. This is the slanted length of the cone. Theta is 180 degree. We can calculate R, and using R draw the top view. Divide it into 8 equal parts. Then draw its front view. Slanted length is known from here, is marked here L, and draw other generators as well. Mark these points in the front view and top view. So this is the front view and top view. A half cone of 50 millimeter base diameter, 70 millimeter axis is standing on its half base on HP with its flat face parallel and nearer to VP. An inextensible string is wound round its surface from one point of base circle and brought back to the same point. If the string is of shortest length, find it and show it on the projections of the cone. So this is the half cone of 50 millimeter base diameter. It is placed in such a way that this face is parallel to VP. Flat face is parallel and nearer to VP. So draw its front view. Now draw the development. This is the cone and this is it consists of a straight line here. That is the triangle at the back. This semicircle is divided into 4 equal divisions. So this portion is divided into 4 equal divisions. This is the shortest distance from A to backside A, or the line is passing through the shortest distance from A, surrounding it, surrounding the coin, and return back to A itself. That is a straight line from A to A. We have to draw it back on the front view and top view. So 1, 2, 3, 4 is at the front side, and at the back it is a straight line from 4 to A. Similarly, from here also we get an arc, and 4 to 1 will be a straight line. 4 to A will be a straight line. A particle which is initially on base circle of a cone standing on HP moves upwards and reaches apex in one complete turn around the cone. Draw its path on projections of cone as well as on its development. Take base circle diameter 50 millimeter and axis 70 millimeter long. Draw the top view first. 50 millimeter diameter, and draw its front view taking 70 millimeter axis. Now draw the development. So this is divided into 8 equal divisions. Now divide O dash and A dash to the same number of divisions done here. Here it is divided into 8. So divide O dash, A dash as well into 8 equal divisions. Now the point starts from A, second point is here, third point is here, fourth point is here, and so on. Fifth point is here. This is the sixth point at the back, seventh point, eighth point, and ninth point. So in front of it we get a clear line, and behind this we get a dashed line. Project these points in top view as well. Mark these points in the development as well. So thank you very much.